For project 1, the assignment was to create an application to help a user in investigating the potential relationship between well nitrate concentration measurements and cancer rates throughout the state of Wisconsin. The requirements were for a user to be able to pass a distance decay coefficient that would be used with the inverse distance weighted interpolation algorithm to create the continuous surfaces needed for well nitrate parts per million and cancer rates throughout the state. I made a decision to design a Java web application using hex grids to examine the potential relationship for these two variables. The application is being deployed on a local instance of a Tomcat server on my home machine. Also on the Tomcat server is GeoServer, which I'm using to serve out all the geospatial layers for this project for my backend Postgres database. The application includes a help modal up here to the right that basically just explains the purpose of the application and some general background on inverse distance weighting. This map layers button here is basically a legend toggle. So you can see right here that the hex grids are grayed out because they haven't been created yet, but you have your well nitrates, you have labels for those nitrate points and the tracks. One of the things that I did was these foundational layers right here are served out as WMS layers. So they're basically images, but they have zoom-based rendering attached to them. So you can see they're styled over here with this legend to the left, but as I zoom in, you will notice that they start to become populated with labels. I decided to do this as opposed to clicking on every individual tract or hovering over every single point to get an idea of what the data looks like. If the points end up being a little bit too distracting in terms of labels, you can toggle those off right here and just look at the cancer tracks. If you want to throw that back on, you can do that as well. If you want to zoom into like a very close area and just look at the well nitrate concentration for that immediate area, that can be done as well. Over to the left are basically the hex grid size parameters, which is in square kilometers, and the distance K coefficient input. Basically the only checks that are set up over here are for preventing the user from entering special characters or letters that would throw an error when they make the request to my server. So for the first example, I'm going to go ahead and enter about 250 as the size for the hex grids and set a distance K coefficient of 1.5. When I hit calculate, a post request is sent to my web application, and a jar file that I basically put on my server to run on the application will go do all the backend logic through my Postgres database in Java's sheet-all bindings to generate the hex grids with the populated standardized residuals that you're going to see here in a few seconds. One of the things you can take a quick look at is within the Tomcat window here, you can see kind of a lot of the fetch requests that are being done. And if you scroll up maybe a little bit, it looks like it does some stuff. Yeah, these are some print statements from my Java application that basically show you going through in some of the different queries and just going step by step and creating the necessary rasters and joining them to the hex grid. So this output here is created by basically sending these two parameters to the server and calculating two rasters using the inverse distance weighted interpolation algorithm. Those two rasters are then joined to these hex grids, which are also generated through the database, and a mean value is calculated for each of those. From there, a linear regression equation is generated to basically make a prediction of the cancer rate based on the well nitrate parts per million concentration. And this output here is basically an assessment of that linear regression equation. So you can see the equation up here to the right in this box. And you can also see the R² value in terms of how well it actually fits the data and how it looks in terms of looking at the actual residuals. So if you zoom in here, you'll notice that Milwaukee is kind of one of those areas where the model severely overpredicts the cancer rate, where you see 13.62 here, but actually 1.34%. You can see that you have predicted rates, actual rates, and residuals attached to these, and just generally paints a decent picture within each area of the state of where the model is over or under predicting that cancer rate. So here's an area where it's under predicting, where it's basically predicting that the cancer rate's around 20%, but the actual rate is more like 46.5. One of the things that you can do with this output is if you want to take a closer look, you can go back up here and you can toggle these hex grids back off. You can turn on those original layers, you can turn the hex grids back, and basically just take a look at the nitrate concentration here relative to these standardized residual hex grid values. Same thing with the tracks here as well. If I want to export my data out and use it in a separate geospatial application, all I would have to do is hit this export button right here. And what that does is make a request to my GeoServer to send back a zip shapefile, which I'm going to save right here. And when I make that change, I'm just going to unzip it over here. And when I do manage to unzip this, if I bring the shapefile over into an application like QGIS, you'll see you have your hex grids with all that data from the database that you can go ahead and do additional analysis with. So, for example, in this instance, all these values here that are being rendered are based on that standardized residual. So that's that column right here, but you've got kind of a few other outputs that are within that table that you could work with in a separate application by extracting that data. If I wanted to make changes or run this again, it's as simple as just entering 2 new inputs. So I'm just going to go ahead and double the hex grid size and then change that inverse distance weighted value to 2.5. And it's just going to make that same request to the server. And what's basically happening, as I was saying before, is that 2 rasters are being created, those hex grids are being created, and those rasters are then being basically joined to those hex grids based on a mean value. From there, you're basically doing your linear regression equation to come up with a model to predict a cancer value based on that well nitrate rate. And from there, I'm calculating the residuals of that predicted versus actual rate, and then the R-squared up here to the top right. So you can see here, the hex grids are a little bit bigger, but the data kind of looks generally the same, where you've kind of got that over prediction happening over here, the under prediction here to the west of Madison, over prediction over here to the northeast. This very similar picture that's being painted each time. One useful thing here is the R-squared value. So what basically I'm using the R-squared value is to use it as an indicator to basically determine whether or not the well nitrate parts per million being measured is a good predictor of cancer rate. Generally, if that R-squared value is closer to 0 than it is to 1, it's usually not a particularly great predictor or a great indicator. And I feel like the standardized residuals kind of back that up, where you're seeing these certain hex grids that are 3 or 4 standardized deviations above the basically the predicted values. So kind of looking at the picture like that, paired with that R-squared value, I would say that well nitrate parts per million is not a particularly great indicator or predictor of cancer rate.